slope fields and separation of variables. Alright guys, this is Professor Feldman here. I'm going to teach you guys how to do some slope fields and separation of variables. We're going to start off with the slope fields. We got a graph here with our coordinates. To find the slope of each point, we're going to plug in the x and y value into the differential equation here. I'm just going to do a few for examples so you guys can get the hang of it. I'm going to take this point first, 1, 2, plug it into the equation. dy over dx equals -2. Plug in the x value, which is 1, over the y value, which is 2. What does that equal? Anybody? Rory?
-1, Professor.
-1. Good job, Roy. So there, that means we're going to draw the slope on the point. It's going to be something like this. You got to relate it to how steep the line's supposed to be. The farther away from 0, the steeper the line usually. Next I'm going to do this point 0, 2. Just erase this other stuff so you can get a better visual, you know. Plug it in. Anybody remember what point I'm doing? 0, 2, thanks. 0. What does 0 slope look like? Horizontal line, just like that. It's easy as that. So now we're going to move on to point -1, 2. It's in the second quadrant, in case you guys didn't know. Plug it in, dy over dx equals -2. What's the x value? -1. What's the y value? Oh, it's 2. What does that equal, Rory? 1. Do you know that's a positive slope? Which means, sorry, if you guys can't see, it's going to go like this, just a little bit. Then I'm just going to fill in the rest for you so you guys we can move on with our lesson. We had another slope of 0. All down the y-axis, slope of 0, again and again. We got another slope of -2, which is, you don't want to make it look like that. It's got to be steeper, so I'm going to go like that. Bada bing, bada boom. This slope is 2, a little bit steeper. This point right here, point -1, point 1, -1, that would be 2 also. So I'm going to draw that. The point below that, 1, -2, that slope would be 1. So I'm going to draw it like this. This point -1, -1, that's a slope of -2. And this slope right here, -1, -2, that'd be a slope of -1. So I'm just gonna make that like that. And slope, I forgot what it's called. Using the slope fields we just created, which gave us many possible solutions to the differential equation -2x over y, we're now going to use the separation of variables method to find one specific solution using the initial condition f of 1 equals -1, which is given to us already. Okay, so to separate the variables, our first step is to cross multiply. We need the y with the dy and the x with the dx. So we get y dy equals -2x dx. Follow me? Good, I'm glad. Then we're going to integrate both sides. What do we get here? We get y squared over 2 equals -x squared plus c. At this point, we're going to use our initial condition, which is given to us, which is 1, -1. We're going to plug that in. -1, square that. Bada bing, bada boom, -1, square that, plus c. We're going to get 1 half equals 1 plus c. 3 halves equals c. Now we're going to use 3 halves, which is our value for c, to find y. So we're going to go back to the first equation. Y squared over 2 equals -x squared plus 3 halves. We're going to times everything by 2. Make things a little bit cleaner. Y squared equals -2x squared plus 3 square root both sides of that. Does anybody have the answer? I got it. I knew you would have. Equals plus or minus. A lot of people forget this. Don't worry, Miss Kaiba, I got you. 3 minus 2x cubed